Hello class, good morning and welcome back to our class. And how was your first long exam? I know it's easy because wala jud mo kuan struggles adto and you said on your post that you enjoyed our exam, right? Okay, so anyways, welcome back. Klase na sadta and we are now on our fourth module. And our fourth module is entitled Rigid Body Equilibrium. And well, this is just an application of all that we have dealt with on the previous topics. And we are now focusing here on rigid bodies. Okay? And so, this chapter covers 3 topics, but I will just summarize these 3 topics into this one video. Okay? Murag balik-balik man gud siya nga discuss sa atong mga previous nga mga lessons. Okay? And for our main goal for this lesson, we have to first talk about the different support reactions because now we are dealing with rigid bodies, and rigid bodies has these different support reactions. And let us just imagine beams, let us just imagine whatever nga mga structural members, and these structural members are supported at those ends, and we should identify what are those supports nga naa nga mga structural members. Okay? And also we have to solve for the reaction forces on those supports, and also we have to learn 2 and 3 force members. What are those 2 force and 3 force members, and how are those important when we are dealing in this subject, when we are talking about that on this subject. Okay? So now for this, in this topic, just take note that we won't be dealing with 3-dimensional nga mga systems because they are much complicated and they are hard to imagine. Ako po dosay mag-struggle kong imagine. And what's important is the concept that you will be able to understand how these things work, and basically can also just condense 3D systems into 2D systems. So it will be a lot easier to analyze 2D systems. Okay, so now let us talk about, as you can remember, when we are talking with the 2D nga mga problems, we are only focusing on coplanar forces, right? So what are those coplanar forces? Again, those are forces that act on the same plane, right? Okay, when you talk about 3D, and ang imo imagine kay ang iyang x, y, and z components, but in here you're just only focusing on the x and y plane. Okay? And when you are dealing with moments on a 2D nga kuan system, the direction of the moment is going towards you or away from you when naasa atong 3D, as what I've said on our previous topics. Okay, so now let us identify these different kinds of support reactions, especially on your beams and on other structural members. And we will also create free body diagrams out of these kinds of support reactions because these are very important, especially as you are going to analyze problems that has these kinds of supports. Okay? Because, again, it is hard to solve problems when you don't know how to analyze the system that you are dealing with. So in order for you to be able to analyze it simpler, then you should create a free body diagram. And indeed, this will greatly help you in analyzing your problems if you are able to create your own free body diagram. Okay, so now let's deal with this. Let's talk about these different kinds of support reactions. For our beams, we have these 3 kinds of support reactions. And kani nga mga kinds of support reactions mo ni ang atong kanunay ibalik-balik diri sa atong statics on the next topics. And we also deal with this one again when we are dealing with mechanics of deformable bodies later on. Not on this subject na, but on your next subjects. So now, what are these three support reactions sa imong mga beams? We have first here, a roller support. Sama na siya, sama na roller support. A roller support looks like this. So for example, if this is your beam, then basically this one is your roller support. Okay, so ako ra nagito nga ang beam ha. Okay? So, can you imagine that one? Just imagine ha, this is the beam. This is not slender, but at least slender siya gamay. And, mao ni imong roller support. So, ingani lang ni siya kitaon. Okay? And, ang imong support, it can roll from left to right, but it supports your beam on the vertical nga component. Okay? So, una pasabot ani. So, inig tanaw siguro nato ani sa 3D, ani yung itsura. And then, adire ang imong roller nga support. Ano lang. Okay, so now, if you have this kind of support, then if you are going to create a free body diagram, how will it look like? Okay, di ba? As you can remember, if we are going to create a free body diagram, ang sa first na tubaton, ato i-isolate ang kadong atong rigid body nga atong i-consider. So, since in this case, we are considering our beam as a rigid body, then, if we are going to make a free body diagram, atong roller support, so ato to i-remove ang atong roller support and convert it into an external force that is acting on this beam, then what will it look like? So basically, ang atong roller support, di ba, niyon ko kaganiha nga, wala siya nag-support sa atong X and Y components because again, as you can see, kung atong nagibutangan og X component nga force ang atong beam, it will not restrict the movement of your beam on your X component. So, pwede ra siya maka-freely og lihok sa atong horizontal nga component. But, kung diri ko nagbutang og force, iya gi-restrict ang atong vertical nga movement. So therefore, this kind of support, ang imong roller support, only restricts your Y component. So your roller support only restricts your Y component nga force, but it doesn't restrict your X component nga force. Okay, so for example, if you have an external, if you are applying a force going there, and let's call this one as P. So, therefore, this roller support here does not restrict the X component of this force, but only the Y component of that force. So, mao lang ni ang iyang gipugnan nga force sa aning atong roller support. Okay? Understood? So, ingana lang. Again, it is called support because it restricts the movement of a rigid body. Pero in this case siguro, kung mao lang ni ang atong support, then of course, muligid ni siya, mo-accelerate ni siya, kay wala may nagpugong ani atong PX. And we have another kind of support that restricts your X and Y forces. And that is what we call your pin support. Unsa naman po ning pin support? So we have this beam na sad. We have this beam. And then you have this leave. And you have this spin. Okay? Sa itsura na niya, kung ato ikuan, ato 3D. Ano yung itsura inig 3D? Hindi mo ka ba maghimong 3D? So, ani ang atong pin support. Sa pasabot day ani, we have this. Kaning imong murag triangle, this is what you call your leave. Okay? And naa kay this one. This is what you call your pin. Your pin and your leave. Since duha man ni sila, so leaves na sila. Murag imong uyab, gi-leaves ka ni. Okay. So, anyway, so this is your pin and this is your leave. Unsay pasabutan ng pin? So, kanang pin, iya na gitusok iyang self dito sa atong beam. So, kay DI, ang atong beam, inigtanaw na to sa kilid, kaning atong beam, na siya bangag dira. And then, dira, tusok ang atong pin. Okay? So, yung ana lang. So, inigtanaw na to ana sa front view. O, diba, daghan na tag view. Morning side view sa imong kuan, sa imong beam, and then maoni ang imong leave. Morning imong other leave. So duha ni sila ka leaves ha. And then ang imong pin muna siya. Uy. Muna siya. Dira. Your pin and your leave. Okay? So yung ang atong pin support. So, for example, balik na pudaan ni nga beam, and then imagine nga kaning beam na siya buslot dere, and then ato gipinan, giingani lang nato ha, giingani nato pagpin. If you are going to create a force going on your x component, then it will restrict the movement of this beam on the x component. And at the same time, if you are going to apply a force on your y component, then it also restricts the movement of your beam on the y component. Because again, it is pinned on this point there. So it restricts your x and y components of your beam. Pero, unsa may inyong nabantayan? How about if you are going to create a rotation out of this beam? Well, since spin man siya and then lingin man na siya, then it can freely rotate. So, this one does not support your moment, but it only restricts the forces along the x and y components. But again, it can rotate your beam. It enables your beam to rotate. Okay? So therefore, if you are going to create a free body diagram of this beam with this pin support, then this is what you are going to draw. So, mga ni, ato nagitanggal ang atong pin kay para ma-isolate nato ang atong beam. So, unsay gi-restrict sa atong pin support? Again, mga ni kung tayong bangag. So, this one restricts your So this one restricts your y component, your Fy, and this one also restricts your x component. Don't mind the direction of these forces. Why? Because you are just making assumptions from these directions. And you will just find out later on when you are going to solve the problem if unsa ang iyang tinod nga direction. Kay if you're going to assume this kind of direction pa left, and if you arrived on the answer nga negative, then you can say nga ang imo dayang assumption nga direction is wrong, so therefore you can just change the direction to going to the right. Nga na lang. Okay? So, mao ni ang atong pin support. It only supports your X and Y components of your beam nga forces. Okay. Another one. Another kind of support. So how about this one? This is what you call a fixed support. So your first kind of support, roller support. Another kind of support is your pin support. And your third kind of support is fixed support. So unsa naman pud ni? So as you can see in this one, this is your beam and this is your wall. Okay? You will just know that this beam here is supported on the wall. Nga gisiminto siya dira sa wall. Nga gifix siya og butang dira sa wall. So, kung dito sa atong roller, it only restricts your Y component. If dito sa atong pin support, it restricts your X and Y components. If there is sa atong fixed support, if you're going to make a free body diagram out of that one, so may restrict. It restricts your X, your Y component. Okay? Kaya diba, imagine nga, giingana na nako ang kaning atong beam. If I'm going to make a force going horizontally, then it restricts the movement of your horizontal force. If you have a force that is applied to this beam going in the Y direction, it also restricts your beam to move on the Y direction. If you're going to create a moment, siguro magbutang na pud kag Y direction nga force, it also restricts moment. So, iya gipugong pud ang moment aning atong beam kung naka-fix siya support. Okay? So, therefore, di ay sa imong fixed support, not only it restricts your X and your Y forces, it also restricts your moment. So therefore, kanusa man ni siya ma-achieve nga makuha nimo ang iyang mga X, Y, and moment? Of course, when your beam is in equilibrium. Kanusa man ang equilibrium ang atong beam? When there are no accelerations nga nahitabo sa imong beam. Kay, for example, mo nimong beam and then dili siya equilibrium, so kung magbutang kag force mo, adto ra siya didto. Pero kani, since equilibrium man siya, so therefore, naadyoy nag-restrict niya og movement. And na-restrict ang movement sa atong beam, it is because of your supports. So therefore, in order for you to stop a force of 10 kilonewtons going here, siguro natay 10 kilonewtons diri nga force, then your support should also be exerting a 10 kilonewton nga force para mo equilibrium na ang atong beam and then di na siya mo lihok. If ang atong beam is subjected to a force of 20 kilonewton diri, then ang atong beam, ang atong support dapat exert pud siya og 20 kilonewton going opposite sa aning atong 20 kilonewton. And since naman tay 20 kilonewton nga force, and then it will create a tendency that this beam will rotate because of moment, and let's say the distance of this one is 2 meters. So, in order for us to stop this, in order for us to restrict the rotation of this one, then our support should create a moment that should restrict the rotation of your 20 kilonewtons, which is, ang imong moment, dapat mag-apply siya og pila man? 40 kilonewton meter nga moment para dili ni maka-create og rotation ng atong 20 kilonewton. Okay? Okay, unsay pasabot na nagbutang kag 20 kilonewton, so imo gipugong ang kaning pag-rotate kay kung wa na nimo gipugong moingan na ra na siya. Okay, moingan na ra na siya kung di nimo pugan. So para mapugong na nimo, then dapat na akay gi-create nga moment po dere. Okay? Ana lang. So we have to deal with this one by using equilibrium equations. So, ganitong mga equilibrium equations, summation of forces is equal to 0. And kaning atong summation of forces, na siya summation of forces along the x equal to 0. And summation of, himo na siyang e. And summation of forces along the y is equal to 0. And then we also have the summation of moments. Point O is equal to 0. So, these are our equilibrium equations. And this is very important, especially when we are going to proceed to other topics later on. Okay, so there are also some other kinds of support reactions shown in our modules. We have their cables, we have their weightless link, roller, rocker, smooth contacting surface, and etc. So all those things masummarize sa gyapon sila atong tulong nga gi-discuss. Okay? For example, kaning atong cable, we have already discussed this one on our previous topic. Our weightless link, mura na siya ang weightless link, mura na siya, let's say, steel ni siya nga bar o niya imo gibutang nga support dire sa atong beam o na atong weightless link. So therefore, ang iyang support is either tension or compression. Okay? Kaya pwede man ang atong link nag-exert po siyang force padung diha. Pero kung cable na siya, then of course ang atong cables, kung ato na i-push ang atong cables, mulutay man na siya. So therefore, this only is exerting kanang tensile or force that is, this one creates a force that is tensile to the beam or iya gibira ang atong beam. Dili na siya makapush sa atong beam kay mulutay na siya. Okay? Napoy giingon diri nga rocker. Unsa man po ng rocker? It is just the same sa imong roller. So, and take note ha, if your surface is oriented at an angle unya mo ni mong roller, so unsa na may dapat mga direction sa atong roller? Dili siya always on the y-axis. It should be normal to the surface. So take note ana. Ang ako giingon kaganiha, adto nga situation atong roller is on the y-axis kung ang atong surface kay horizontal. Pero kung naa siya angle of theta siguro, then the direction of your support reaction sa imong roller or sa imong rocker should be directed normal or perpendicular sa imong surface. Okay? And etc. So, etc. ng uban kay pare-parehas lag concept sa akong i-discuss. Okay. Sige daw, let's have this example. Kaning nga example, we are only kaning nga example, ang ato lang goal is to create a free body diagram out of this figure that we have. So we have this foot lever. And this foot lever, naa siya atong weightless link, naa siya atong spring, and naa siya atong pin. Okay? Ang kanang pin mo nang nasa A, ang weightless link mo nang atong B, and then atay spring diha sa atong tunga sa A ug B. So, we have to create a free body diagram with this system nga naani mo dire. Unsay goal sa atong free body diagram? Atoy isolate ang atong rigid nga body. Unsa man atong rigid body diha? Ang kanang atong kaning atong foot lever. Okay, so this is your foot lever. Okay, so this is your foot lever, and then this is your link diri sa atong weightless link, maoning sa imong spring, and then maoning sa imong pin support. Go. So first, dira sa imong point B, you have your weightless link. And karon unsa may direction na ni atong weightless link? Since you are applying a force diri sa atong lever, and it is said nga na a force da sa atong link of 20 pounds. So therefore, di ba maoning atong link dire, and then nagbutang ta og force. So unsay mahitabo sa atong link? Di ba mabira ang atong link. So therefore, ang atong link will also create a pulling force dira sa atong lever. So therefore, the direction of our weightless link is going there. Okay? And this is 20 pounds. Okay? Dili siya padong dere. Kay kung padong siya diha, wala na siya nag-support sa atong force nga F. Wala niya gipugong ang atong force nga F. Diba? Okay. So, mo nang padong dito. Also, at the same time, ang atong spring, iya pod gibira ang kaning atong kaning atong spring, iya pod gi-support ang atong force nga F. So therefore, the direction of our spring is also going to the right, which is 30 pounds. And now, how about kaning diri sa atong pin support? Di ba naka-learn ta bago pa nga ang atong pin support only supports your X and Y components sa force. So therefore, your pin support is exerting this kind of forces, your AX and your AY. Okay? So, mo na ang free body diagram sa atong drawing dere. And sige, sir, can we identify these forces? 1, 2, and 3? Yes, we can. We can identify F, we can identify AX, and we can identify AY. How? First of all, we can just easily identify your AX. How can you identify your AX? If you are going to sum the forces along the X. And let's assume, di ba, kung mag-sum tag forces atong X, mag-assume ta og positive nga direction. Ako i-assume nga positive direction is going to the left. Okay? So therefore, ang mga forces nga going to the left mo ng positive, so AX minus 30 pounds minus 20. Bahala na, kasabot na sila na. Minus 20 pounds. Is equal to 0. So, unsa man na siya? Therefore, our AX is just 50 pounds. Okay. So, sakto ang atong assumption sa direction sa atong AX kay positive ang atong answer. If ato ni siya ibutang to the right, mo negative ni siya. And then ato i-adjust ang atong direction. So, may nga ni gyapon na siya. Okay? So, your AX di is supporting at a force of 50 pounds. Of course, because you have your 20 and your 30, and ang sum ana nila mao nang iyang gipugong. Okay, which is 50 pounds. Now, how about this one? How can we solve this one? If we are going to sum this one on your y, assuming that the direction of your positive is going up, so imong button is ay minus f is equal to 0. Take note ha, equal to 0 ni tanan kay equilibrium atong gidiscuss. Okay. We have two unknowns. We cannot answer this one by using this equation only. But we can solve for either of the two using summation of moments. Summation of moments. Sige, diri kung tayo mag-moment at point A. And then, ato i-assume nga ang direction sa atong F is positive, which is going counterclockwise. Equals to F, say distance ani? 5 inches. So F times 5 inches. Sunod. 0 niya atong AX ug AY kay diri ta nag-moment, di ba? Kaning 30 pounds, is this positive or negative? This is minus 30 pounds times distance anak niya. Given the ray, this is 1 inch. This is 1.5 inch. Okay. 30 pounds times 1 inch. Negative 20 pounds times 1.5 inch ibutang? No. Ang ibutang kay 1.5 plus 1. So, 2.5 inches. Equals to 0. So, with this one, you can solve for F. And what is F? Kiba mo mag-shift solve? Kung di mo kiba pag-shift solve, pag-request mo sa atong PSAB nga or nga mag-tutorials o unsaon na pag-shift solve sa calcio. Kaya ang gamit na ng shift solve, dili na ka mag-transpose ani nga mga values to the right. Pwede rin mo gamiton nga equation and then you can immediately solve for F, which is 16 pounds. Okay. So your FDI is creating a force of 16 pounds. Assuming ha, nga wala ni naglihok siya kay equilibrium man. Okay? And lastly, for our AY, so since this one is 16 pounds, so therefore, your AY is also 16 pounds. Now, we have solved for the unknowns, 1, 2, and 3. Okay? By using our equilibrium equations, your summation of forces along the X, summation of forces along the Y, and summation of moments at point A. And take note, you should know asa ka magbutang og moment. Kaya naay criteria sa pagpili ug asa ka magbutang sa imong moment. Ako nagbutang ko sa akong moment diri sa point A para makancel ang atong AX ug AY para gamay na lang akong sulbonon. Okay? Pwede ka mag-moment diri, pero ang problema ay mag-moment ka dere naa paghapon ni imong unknown nga AY. Okay? So, para matanggal nimo ang AY, so diha ka mag-moment kay para usalay anon mabilin. And then masolve na nimo, and then kung masolve na nimo, usa na lang kaano ng imong pangitaon. So you can also solve for AY. Okay? Kamo ang bahala kung asa mo mag-moment basta madiskarte ang inyong pagpili sa location. Understood? Okay. Easy breezy. So we have here another example. Natay unloaded platform dere. Natay platform nga gisuspend siya. Dili gud suspend nga wala siya gipa skwela basta gibitay siya. Okay? And ang platform daw has a mass of 200 kilograms. So we have to create a free body diagram out of it, and let us also solve for the unknown reactions of this one. Sige. So let's first draw the free body diagram of this platform. Okay. So this is your platform daw. And then according to our drawing, na siya'y tension padong nga direction. Let's call this one T at an angle of 70 degrees. Okay? Okay. As you can see, na siya'y cable dira nga gi-support dira sa atong platform. And giingon diri nga ang atong platform na siya mass of 200 kilograms. And then it is assumed that ang kana nga 200 kilograms is located on its center of gravity. Ingana usually ang atong pag-assume nga if you are given the mass or the weight of an object, ang atong assumption kanunay is to apply that weight at the center of gravity of that object or that structural member. Kay di ba, as you can recall dito sa atong simplification of kanang loads, we have that distributed load. And then ato gipangita ang resultant force anang atong distributed load, and then ato siya gi-specify ug unsa na siya nga location. So ingana gyapon siya diri. Kay kadto, basically that was the center of gravity ang katong location sa atong X bar. And mao po na dire, ang kani atong center of gravity mao kun tayo po na atong X bar nga location. Okay? So this is where the force is applied. This is your 200 kilograms. Okay. And unsa pa man ang forces nga naa dire? As you can see, it is said here that this platform is supported by a pin support. So therefore, it also restricts your AY and your AX. And again, take note, I'm just assuming the direction. Ako lang nagibutang-butang ngayong ani kay mo'y ako feel. Kay padong man ubos ng atong 200 kilograms, so probably, para i-support siya, dapat babaw ang atong AY. Kaning atong T, naman siya component nga padong dito, so dapat siguro atong AX, iya ipugong padong sa opposite direction. Okay? Ingana lang ang akong analysis. So, I may be wrong, pero I think sakto. Char. So, kana sa gani kayo makibaw nga sayo pang imong assumption if your answer is negative. Okay? Sige, ako na lang ituyo nga sayop ko, char. Ako ibuta nga ang direction sa atong AX pa daw siya dito. Okay. So, ang atong dapat isolve ani is ang atong T, ang atong AX ug atong AY. Can we solve this one? Sir, usara man atong given, sir, masolve din na natong tulo. Yes, we can. Okay, hanas baya ta. Okay, so how can we solve that one? How can we solve this one? If we're going to sum these forces along the x, sige daw, ato tan-awon be. Summation of forces along the x. And then let's just say that our direction is going there, ang positive. Sige, at unsa may naa? Ax plus mana? T cosine of 70 degrees. Ala, nakalimot na sila ani. Napabaylayan nga x component, wala na. Equals to 0. We have two unknowns. 1, 2. So we cannot solve this one yet. How about summation of forces along the y? Sige, going up ta kay 1. Ay plus t sine 70 degrees minus 200 kilograms man ni siya, so times 9.806 meters per second squared equals to 0. We still have two unknowns in this equation. Pila naman kabuk unknown? Usa, duha, tulo. So di ba nakibawta nga kung natay tulo ka unknown, dapat napud tay tulo ka equation. So saan man eh? Well, nay usa ka equation nga importante kay dire kaning atong summation of moments. The question, asa ka ta mag-moment dere? Mag-moment ba ta dere? Pwede ta mag-moment dere? Pwede man ta mag-moment dere. Pero is it reasonable for us to apply our moment here? No. Kaya diba sa atong criteria, sa atong moment, kung magpili gani kag moment, pilian ng kanang daghag unknown nga forces nga maigo, nga ma-cancel out sila. So asa may daghan nga unknown forces kani? Pwede ba ka dere mag-moment? Pwede god, pero dili siya ang best nga location nga mag-moment ka. What if diri ta mag-moment? Kung dira ta mag-moment, well, of course, our AX and our AY will cancel out. Okay? Naigo man sila sa atong axis of moment. So this is, I think, the best place nga mag-moment ta. Char. O, dira mo maglingkod, maghilak mo, pero charot lang to. This is the best location of this platform para mag-apply sa itong moment. So therefore, summation of moment at A. Now, what is the direction? Let us just assume that the direction is going counterclockwise. Is equal to, again, nag-assume lang kong direction ha, pero ang kaning akong pag-assume og direction, kuan po ni, reasonable ni nga assumption. Ngano man, kay ako gisundog ang, kay ako gi positive ang atong unknown. Kay di ba ang atong unknown ani kay, kung kani ang atong direction sa atong moment is positive man ang atong unknown. So, mao nang ako gi counterclockwise. So man eh. So, summation of moment at point A, una ta sa atong vertical nga component which is t sine 70. Moment arm of pila man? So, this is our, so atong moment arm is from here to here. Diba? Kaya dira man atong application. So, 1.4 plus 0.8. So, pila man na? Pila? 4, 5, 6, 7, 8, 9, 10, 11, 12. 2.2. 2.2 meters. Okay? Napatay y component ani. Ay x component. Plus ni siya kay di ba? It will create a counterclockwise nga direction. plus ni siya, since it also creates a counterclockwise direction. Okay, so plus t cosine 70 times perpendicular distance from here to here, which is given the ray 1 meter. So therefore, this is 1 meter. And then, napatay ka nga force, which is, unsa man nga direction iya ma-create? It creates a clockwise direction, so minus 200 kilograms times 9.806 meters per second squared times moment arm of 1.4 meters. Equals to 0 ka equilibrium. So therefore, your answer sa imong, again, ato ni shift solve kay para di na ta mag-transpose. So, your answer here for your T is 1,139.60 newtons. Okay? So, morning answer sa imong T. O, nakasolve na tag-isa. OMG. Okay. And by using this value, we can solve for AX and AY. Sige, dira taon na sa itong AX. So, AX is equal to, sige, ato ni tanaw ang equation ha. Ako gibali ang direction sa atong AX kung nihabaya. So, dapat ang answer ani is negative. Oh my gosh. So, sige. AX plus 1,139.6 cosine of 70 equals to 0. So, your answer here is negative 389.77 newtons. So, di ba? Sakto ko nga kung nga itong direction negative siya. So, dapat, kung positive na siya, 389.77 newtons going there. That is our final answer for our AX. And for our AY, so AY plus 1,139.6 sine of 70 minus 200 times 9.806 equals to 0. Then, your answer for your AY is equal to 890.33 newtons. And sakto atong assumption, so this is going up. So, now we already have solved for the three unknowns, 1, 2, and 3. By having only one known nga value. Diba? Easy. Okay, so let's have another example. And this one, we are now dealing with beams. And this beam is supported with two support reactions. So, let's have this one. So we have to determine the vertical and horizontal components of the reactions of this beam. Okay? So on the right side of this beam, this is supported by a pin support. And on the left side, it is supported by a rocker. Okay? So pin support and a rocker. Again, your rocker has the same function of your roller support. Okay? Sige. So let's first draw the problem. Okay, so these are the three forces that is acting on this beam. But this is not yet your free body diagram because kung maghimo ganit ang free body diagram, again, we should isolate the beam and remove all the external reactions. And the external reactions that we have not yet accounted are your pin support and your roller support or your rocker support. So, ato sana siya bayluan. And again, for your pin support, unsa gani na to atong gi-support sa atong pin. Okay, so this is your pin, this is BY. And sige, unsa may ato i-assume nga direction sa atong X component, BX. Para ma-positive ang atong BX. So, dapat para ma-positive atong BX since your 600 newtons is going to the right. So, therefore, para i-support sa atong BX, it should be going to the left. Okay? The same sa atong BY, since all your forces, 200, 100, and 600 newtons are going down. So, to support it, then your BY should be going up. Okay. And for your rocker support, di ba, iniyon ko again, rocker is the same sa imong roller support. So, therefore, it only supports Y component. This is AY. Now, sige, para ninyo, unsay una na itong equation nga gamiton sa itong summation of forces along the X, summation of forces along the Y, or summation of moments. Asa may pinaka-reasonable adto unahon? Sige, ato i-analyze. Kung mag-summation of forces along the X ta, can we immediately solve for RBX? Yes, we can. Because, nga naman, we only have one known, because duha lang sila ka-X component and the other one is known. Okay? How about if we are going to sum the forces along the Y? 1, 2, 3, 4, 5. So, and out of that 5 forces, we have 2 unknowns. So, for you to be able to solve your 2 unknowns, you also should need 2 equations. But you can use BX because X component man siya. So, we cannot use Y to directly solve for AY and BY. How about the moment? Can we sum the moments at AY? If we're going to sum the moments about AY, makancel ang BX, makancel ang AY. And we can solve for BY. Or, on the other hand, we can also sum the moments at point B para makancel ang atong BY, ang atong BX, ug ang atong 200 newtons. And we can solve for AY. Naalang na nimo, you can either choose sa AY baka mag-moment or sa BY. Okay, pero ato unahon tong BX, ato unahon solve ang atong BX. Summation of forces along the X going there is equal to, again, ako nag-assume nga going to the left ang positive kay ang atong BX is going to the left. So, para ma-positive atong BX, then, ito i-assume nga going to the left. So, BX minus 600 cosine of 45 degrees equals to 0. So, therefore, your BX DI is equal to 424.26 newtons. Okay? So therefore, your X is going that direction. This is your final answer. Pero, mangita pa ka sa AY o BY. Sige. So, unsay unahan na to o gamit ang summation of forces along the Y or summation of moments. It is better for us to use summation of moments first. mag-summation of forces along the y-ta, we have two unknowns. Okay? So, summation of moments. Sige. Asa man ta mag-moment? Asa man mo mas ganahan mag-moment? Diri sa AY or sa BY? Kaya di ba, kung mag-moment ta sa AY, makancel nga unknown is your AY and your BX, which is known ang puning BX, so mabilin ang BY. So, possible nga pwede ta mag-moment diri sa AY para ma-solve ang BY. But, kung tapulan mo nga pagkatao, kay kung mag-moment mo diri, magbutang pa kaani, so daghana kag butangon. So, pero kung dili ka mag-moment, kaning tulo dayon ang makancel nga forces, and then ang mabili na lang og butang nimo kay kani og kani. Sige, ako kay dili man ko tapulan, so diri ko sa AY mag-moment. Sige. Para maka-try tag another nga location po nga dili makancel ang BX ug BY. Sige. So summation of moments at point A, so this is your point A. Ang kaning atong point A na locate siya sa tunga sa atong beam. Okay. So unahon nato, BY times 8 minus 200 times 8, which is this one, minus 100 times 5, sunod, dirita. Sige, tanawa ni dire. Una ta sa Y component. Okay? Una ta sa Y component aning atong 600 newtons. Minus 600 sine of 45, di ba, mauning Y component sa atong 600 newtons. And then moment arm of 2. Pero, take note, diri sa atong example, iya gi-consider ang thickness ani. So, di ba kay naman ta x component aning atong 600 newtons. And ang kanang atong x component is located at the surface of the of this beam. Wala siya na-locate diri sa kuan sa atong beam, sa tunga sa atong beam. So nagyapon siya perpendicular distance dira nga gamay. Okay? And gihatag dira given nga 0.2 na nga distance. So we still have to consider that one. Okay? So therefore, kung ingana ang direction sa atong kuan, sa atong force sa 600, is it positive or negative? That is negative gihapon. So minus 600 cosine of 45 times 0.2 and equals to 0. So let us check sa atong BY. So your BY here is okay guys, sayop na ito sa pagbutang og 3 dito kaganiha kay 2 di ito dapat. So therefore, so instead of kadto kay 8, this is only 7 because 2 plus 3 plus 2, 5, 6, 7. Okay? And this one is 5, this one is 2, so this one is correct. Therefore, okay, let's check. So this is 404.77 newtons. And sakto ato assumption, this is going up. Okay. And now let's look for your AY. To solve for your AY, then you should use summation of forces along the Y. And assume that your AY direction is positive going up. AY plus 404.77 minus 600 sine of 45 minus 100 newtons minus 200 newtons is equal to 0. Then your AY should have an answer of x plus ans minus 600 sine 45 minus 100 minus 200 equals to 0. Your answer here is 319.50 newtons. And this one is going up. So, these are your unknown reactions on your pin and your rocker, and your rocker support. Okay, di ba? Sayon lang. Now, another example. We have this here, a pulley. This one is a frictionless pulley, they say, and ang kaning atong pulley gibira diri sa atong vertical nga cable 100 pounds. Okay, and ato daw pangita ang support dira sa atong pulley, which is pin support na siya. Okay? Ato pangita ang tension sa cord C, and we also have to look for the vertical and horizontal components of your pin at A. Okay. Okay. Let's first draw our pulley. And now, this is our free body diagram of our pulley. Okay? And this one is given daw nga 30 degrees daw na siya. Okay. The goal of this problem is to solve for t and to solve for ax and ay. But I think this is so very obvious that your t is equal to what? 100 pounds. Ano makaingon man ta ana? Kay nagbira man kag 100 pounds dira, and kaning atong pikas nga cord is fixed on the wall, then of course it will create the same amount of force diri sa atong 100 pound. Okay? Tension raman ni sa atong cable. So obviously, this is still 100 pounds. And if you just want to prove it, we can use summation of moments at A to prove it. Sige, ato ay clockwise. And then, dirita una. Given that the radius of this one is 0.5 feet. Okay. So, the radius is 0.5 feet. So, summation of moments at point A, what is 100? Una sa ta sa t kay positive, t times 0.5 minus 100 times 0.5 equals to 0. So obviously your t is 100 pounds, which is the same, which is obvious. Okay? So now, let's solve for your ax and your ay. Unsa may una na ito nga ma-solve diri? We can either choose between the two, your ay or your ax, for us to be able to solve immediately for these unknown supports. Una ta sa ax, kay unahon ba yung x, di ba? Sige, ax, summation of forces along the x. Going there, kay x na to, going there, ax, napatay x component dari, kani, minus 100 pounds sine of 30 degrees equals to 0. So your ax here is 50 pounds. And that is going that direction. So, this is your final answer sa imong t. This is your final answer sa imong ax. And for your summation of forces along the y, going up, you have your ay minus 100 pounds, which is this one, minus 100 cosine of 30 degrees equals to 0. So your ay here is 186.60 pounds. Going So this is your final answer for this problem. Ba, easy breezy. Last example, we have this member that is pin connected at A. So at point A, pin connected ni siya. Okay? And at point B, it rests at a smooth support. Okay? So smooth support, still the same function sa atong roller support, which acts normal to the surface at point B. So determine daw the horizontal and vertical components of the pin A. So you have seen the problem, and what we are going to do now is to make a free body diagram out of that one. So mao nang imong sa pin A, nambot na siya yung ana. Okay. So let us expose all the forces. Di ba kay smooth support man to na adere? And ingon ta nga kung smooth support dapat perpendicular sa surface. So ingani ang surface na dito, so ingana ato smooth support. Okay? Let's call this one normal B. And that is oriented 30 degrees. Okay. We have a triangular loading dere. Diba? And we already knew how to simplify a triangular loading, right? Diba? Kung naamoy ing ani nga kind of distributed loading, you can just get the resultant force of this one by how? Since this one is a triangle, then you should get the area of the triangle, which is unsay maximum load dire. So at this point di ay ang iyang load is 80 Newton per meter. So mao ning height sa atong triangle. Ang length sa atong triangle is given 1.5 meters. So therefore, ang atong resultant force aning atong triangle is unsa man? FR, ako lang ibutang ana ha, FRT is equal to, diba, 1/2 because triangle base 1.5 meters times height of 80 Newton per meter. So your answer here is 0.5 times 1.5 times 8. Your answer here is 6 newtons. Nya asa man na siya na-locate nga force? Diba we learned that your resultant force should be located where? 1/3 from the largest end of this triangle and 2/3 from the smallest end. So, nakita na siya nga naana siya diri 6 newtons. I mean 60 newtons. So, this one is 1 meter and this one is 0.5 meters. 1/3 of 1.5 and 2/3 of 1.5. Okay? And take note, siguro new concept ni ninyo, we have a moment here of 90 Newton meter. Sa so, moment? Apply lang siya moment dira nga part. Okay, ana lang. Okay. And we have here a pin support, and we know that our pin support supports both x and y components. This is your AY and your AX. Okay, and the goal of the problem is to solve for AX and AY and NB. So may pwede una nato pangitaon ani. Ang pinaka-diretso nato nga mapangita. Of course, ang atong NB. If what? If we are going to sum the moments about point A. Kaya kung mag-sum tag moments about point A, makancel ang imong X o ang imong Y. And then mabili ng NB. Now, if you're going to sum the forces along the X, you have a known and you have another unknown. So you can solve if you're going to sum the forces along the X. If you're going to sum the forces along the Y, you have one unknown and another unknown because this has X and Y components. So, di na nimo ma-solve diretso. Pero kung mag-moment ka about point A, mas-solve mo dayon ng NB. Kaya mo naman yung unknown. Sige. Summation of moments at point A, assuming that your direction of NB, since it can create a counterclockwise direction, so counterclockwise po ito diha. So, mani, NB, moment arm, di na ta kailan mag X and Y components sa itong NB kay naa naman siya yung moment arm dira with of 0.75. So, times 0.75. Sunod, kani, minus 60 newtons times 1 meter. Diba? 60 newtons, 1 meter. Okay? And then, take note, we have a moment. There is an external moment that is applied in this one, which is clockwise direction nga 19 newton meter. So, since ang atong pag-sum is positive ang counterclockwise, therefore, this one should be negative 90 newton meter. Take note, mag-sum ka sa moment na kay external moment, di nimo siya butangan og moment arm. Kay moment naman siya. Kung force lang siya, diha ka magbutang og moment arm. Pero kung ano kay moment naman siya daan, di na ka magbutang moment arm. Because this one is a free vector. So, anywhere nga na-locate na siya, it doesn't matter. Okay? So, 90 newton meter lang yung ibutang nila. Napatay lain? 1, 2, and 3. 1, 2, and 3. So, wala na. Equals to 0. So, your NB here is 200 newtons. Okay? Diba? Kuha na yun. Now, since your NB is now determined, then we can solve either your X and Y. Okay. So, una ta sa summation of forces along the X going at that direction, which is AX minus 200, which is your NB, sine of 30, sine, kay diba, this is your 30 and that is your X component. Napatay lain nga X component, kani ug kanira man, so wala na, equals to 0. So your AX DI is equal to 100 newtons going to the left. Kani going 30 degrees. Okay. And lastly, summation of forces along the Y going up is equal to AY minus 200 NB cosine of 30. We still have another Y component minus 60 newtons is equal to 0. So that is minus 200 cosine 30 minus 60 equals to... So your AY here is equal to 233.21 newtons going up. So these are your final answers for this problem. So this one is easy. Sayo na lang, mubura ang solution because this is just the basic part of this. This is just the introductory part of this very long mga lessons. Okay? Understood? I hope you did because we have a lot of examples. I guess we have 5 examples and shadow sa atong 5 examples, you have learned nothing, right? So as a summary for this lesson, we have talked about rigid body equilibrium, and we have dealt with rigid bodies na. We have applied equilibrium equations on these rigid bodies, and we also have identified new kinds of supports, which are your pin support, your roller support, and your fixed support. I haven't given yet an example of your fixed support, but later on, as we continue in this topic, then I might give you. Okay? So if you don't have any questions, if you have things that you still don't understand, then it is good if you're going to ask questions to me directly in Messenger perhaps, or on the comment section of this video. So then if you don't have any questions, then good for you. If you understand the lesson, then very good for you. So we still have another topic to discuss later on, and we'll be back in a few minutes.